Hello, sixth graders. I sure have missed you this week. But I hope you have been watching those videos, and those of you that had me in class last Friday, that you have learned what GCF is and you understand it. But just in case you don't know, maybe this video I'm making today will help you. But before I get started with problems, I want to ask you, what is GCF? What's it stand for? Well, GCF stands for Greatest Common Factor. But can we find greatest common factor if we don't know what factors are? What is a factor? Think. What's a factor? A factor is a number that can evenly divide into another number without a remainder. For example, 4 times 5 is 20, right? So 20 divided by 4 is 5, and 20 divided by 5 is 4. That makes 4 and 5 factors of 20 because it can evenly divide without remainders. Okay, so today in this video, the videos I'm uploading, you are going to see me do a problem using the listing method, the prime factorization method, and the ladder method. And I sure hope if you've been struggling, I hope this helps some. The first problem we're going to look at today is the greatest common factor of 20 and 24 using the listing method. Okay, to do the listing method, what you're doing, you want to find all the factors of both 20 and 24, and then look at the common factors, and then find the greatest common factor of the two. So let's look at 20 first. Let's find all the factors of 20. So starting with 1. 1 goes into 20 how many times? That's right, that's pretty easy, isn't it? 20. Okay, now let's look at 2. 20 is an even number, so you know all even numbers are divisible by 2. So 2 times what gives you 20? Well, half of 20 is 10, isn't it? So 2 and 20. Now let's look at 3. In using the divisibility rules for 3, you add the sum of the digits of the number. 2 plus 0 gives you 2, right? 3 can't evenly go into 2, can it? So that means 20 is not divisible by 3 either. So let's move on to 4. 4 times what gives 20? 4 times 5, doesn't it? Now 20 divided by 5 is 4, and we repeat, don't we? We already have a 4 and a 5. So that tells us, when we repeat, that tells us you found all the factors. So you can stop there. Okay, so now we get a stop. Now we move on to 24. Well, start with 1 again. 1 in itself, right? 1 and 24. Is 24 an even number? It sure is, isn't it? So that means it's divisible by 2. Well, what's half of 24? That's it, 12. So 2 times 12 is 24. Now let's look at 3. Remember over there, divisibility rule for 3, if you add the digits, the sum of the digits is divisible by 3, then the number's divisible by 3. Well, 2 plus 4 is 6. 3 can go into 6 2 times, can it? So that means it's divisible by 3. Well, if you know your multiplication facts, 3 times 8 is 24. Now 4 and 6. 5 can't because it doesn't end with a 0 or a 5. 6 can, but that repeats. Remember over here what I told you when you repeat? When you repeat, that tells you have all your factors now, so you can stop. So let's come down here, and what are the factors of 20? Well, let's look up here. 1, 2, and 4, and then 5, 10, and 20. Now let's list the factors of 24. 1, 2, 3, and 4. 1, 2, 3, and 4. Then at 6, 8, 12, and 24. So 6, 8, 12, and 24. Okay, now we have to find out, what do they have in common? What factors is in 20 that's also in 24? Well, there's a 1, 2. Well, here we have a 3, but 20 doesn't have a 3. So they don't have a 3 in common. Here's a 4 and a 4. Now nothing else is in common. So the common factors then of 20 and 24 are 1, 2, and 4. So then the greatest common factor, well, which one of those numbers is the biggest? 1, 2, or 4? That's it, 4. So then the GCF, the greatest common factor of 20 and 24 is 4. 4 goes into 25 times, and 4 goes into 24 6 times. So the GCF would be 4. Okay, so now we are going to use the prime factorization of 20 and 24 to find the greatest common factor. To do that, we have to find the prime factorization of each one. So 20, what multiplies to give us 20? You can use 2 and 10. You can use 4 and 5. You cannot use 1 and 20. You cannot use 1 when finding the prime factorization. So we'll just use 4 times 5. Okay, now in prime factorization, if you remember from 5th grade, prime factorization, you have to find the number that is prime. Okay, if it is prime, you're finished factoring it down. So let's look at 4. It's an even number. Even numbers can always have what number can go into them. If you remember, all even numbers can evenly be divided by 2. So the only even number that's prime would be what? Think. It would be 2. So we can factor 4 on down. Can we factor 5 on down? What goes into 5? Remember, to be prime, only 1 in itself can divide into it evenly. Well, 2, 3, and 4 can't go into 5 evenly, so only 1 and 5 can. So that makes 5 a prime number. So you can circle 5. We're finished with 5. Okay? Now let's look at 4. What multiplies to give us 4? 2 times 2. They are both prime. Remember what I said about 2? It's the only even number that is prime. So the prime factorization for 20 would be 2 times 2 times 5. Now normally we would say 2 to the 2nd power times 5. But to make it easier, we're going to leave it like this. Now let's look at 24. Same thing over there. You can use 4 times 6. You can use 3 times 8. You can use 2 times 12. We're just going to use 3 and 8. It's going to give you the same answer no matter which one you choose. 3 is prime because only 1 and 3 can go into it. 8 is not. So we have to factor 8 on down, which would be 4 and 2. Okay? 2 is prime. 4 is not. Let's multiply 4. What can multiply to give us 4? 2 times 2. So now we're finished there. So then 24 would be, go over here, it would be 3 2s and 1 3. 2 times 2 times 2 times 3. And to check it, go 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24, which is what it has to be right. Let's check 20 now. 2 times 2 is 4. 4 times 5 is 20. They are all prime numbers, so we have found the prime factorization of both 20 and 24. Now, to find the greatest common factor, you find the ones they have in common. So they have a 2 in common. They have another 2 in common. This one has a 5, but this one does. 24 doesn't. 24 has another 2 and a 3, but there's not one up here. So then you pull that out, and you pull out what they had in common, which was a 1, 2, and 1, 2. So 2 times 2 gives you 4. So that's using prime factorization, okay? Now let's find the GCF using the ladder method. If you look at it, it looks like a what? It looks like an upside down division sign, doesn't it? So now we're going to look at 20 and 24. What can factor out of 20 and 24? Well, they're both even numbers, aren't they? So let's factor out a 2. Now, 20 divided by 2 gives you what? 10, doesn't it? Okay, so put the 10 underneath the 20. Now, 24 divided by 2 gives you what? 12. So now let's look at these numbers. Are these numbers prime? There's still something that can factor out of both of them, aren't they, besides 1? So now we're going to factor it again. What can go into 10 and 12? What's a factor of both? So we can do 2 again. 10 divided by 2 gives you 5. 12 divided by 2 gives you 6, doesn't it? Now, can 5 and 6, do they have a number that can go into each one of them, a factor that can go into each one of them without it being 1? There isn't, is there? So that means we are finished, okay? So let's look. To find the answer then to the problem up here, the GCF of 20 and 24, you go and you multiply the numbers to the side. So 2 then times 2 equals 4. So there we are again with the 4. So then the greatest common factor of 20 and 24 is 4. So now we have done the listing method, we've done prime factorization method, we've done the ladder method, haven't we? Now also you can check too. If you go 20 now divided by 4 gives you 5. 24 divided by 4 gives you 6. That lets you know you are correct too, okay? So I hope this has helped you a little bit, and I can't wait to see you in class. Until next time.